Okay, for our second video for geometric and spatial reasoning, standard 4.1, we'll look at the segment addition postulate that says if points A, B, and C are on the same line segment with B between A and C, then this is true. And a little subtle here, notice that AB right here has no symbol over it. That means distance. So it's not talking about a figure, it's talking about a number, the distance between A and B. So we're saying the distance from A to B plus the distance from B to C is the entire distance, which makes sense. Now, a postulate is a rule that is accepted without proof. Okay, so let's look at this in application. So here we have a line segment XZ, which is split in two parts, 51 and an unknown part, and it totals 88. So if we're looking for YZ again, which means the distance between Y and Z, we'd set up the segment addition postulate. Part plus part equals whole. Substitute 51 for XY and 88 for XZ, and then use simple algebra to find YZ to be 37. Okay, so again, these are distances, and this particular figure is not necessarily drawn to scale. We can make this algebraic, find AB, the distance there. So we'll color code this one. AB plus BC is AC. Again, part plus part equals whole. 2x is AB in yellow. 3x plus 5 in red, that's BC. 40 is the entire distance, as you can see with this little brace. Now some algebra. That's 5x plus 5 if you combine like terms. Subtract 5 from each side to get 5x equal to 35. On to the next slide. We're going to divide by 5. Now we have to be careful. The question did ask for segment length AB, not x. So we need to plug 7 into the expression 2x to find AB. So the answer is 14. The angle addition postulate is very similar. It says if a third ray is placed in the interior of an angle, the sum of the measures of the smaller two angles equals the measure of the original angle. So notice again some notation. This little M, when we change from angle 1, which would refer to the picture that you see, M refers to the number associated with that picture. That is the measure of it. Okay, so the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle PQR. And it's assumed that from an earlier course you have some concept of angle measure. Okay, so find the measure of angle ABC. Remember ABC, follow the letters, is this large angle. The segment addition postulate says the two parts ABD and DBC, follow the letters, equals the whole thing, ABC. Measure of angle ABD is 30, measure of angle DBC is 40, and then simple addition here. Measure of angle ABC is 70 degrees. Notice we put the degree here when we're done. We don't necessarily have to put degrees the whole way, but when we present our answer, we want to say degrees. If you remember from earlier, that looks like a 70-degree angle. I mean, we can't tell exactly with our protractor, but we know 90 degrees would be straight up here, and that looks reasonable to be 70. Okay, again, we can go algebraic here. We won't actually show the angle addition postulate. The measure of angle, it says ABC, that should say EFH here, so that's a typo, that should say EFH. But we're going to say 42 plus 12x minus 4 is equal to 122. Okay, so 42 plus 12x minus 4 is equal to 122. And now we'll use algebra. 12x plus 38 is 122. Subtract 38 from both sides. 12x is 84. And this time we're only looking for x. So x is equal to 7. Again, the first part of the standard doesn't mention either of these postulates, but the supplementary material for the standard does list it. I'll list those two, so that's why we're going over it. Now, there's a second part of the standard which seems to be preliminary, sort of a preview. We're not going to do much with this, but arc is a portion of the circumference of a circle. Now, we're certainly going to look at this more in a future chapter, but for now, you have some concept of a circle, the circumference being all the way around. AB, which is indicated like this, would be a portion of that. Okay, so the reason we mention that is in the standard. This is the second part, distance around a circular arc, to develop and use precise definitions and symbolic notations to prove theorems and solve geometric problems. Now, this last part is very vague, and we'll do this throughout the course.